Welcome to Discover and Explore, your ultimate guide to the discovery of the world's most fascinating things and understanding the wonders of nature. Today, we will explore the topic of deep foundations in structural engineering. A deep foundation is a type of foundation that extends below the ground surface to a depth where the soil or rock is capable of supporting the weight of the structure. Deep foundations are used when the soil near the surface is weak or unstable, or when the structure is heavy or subjected to significant loads. Types of deep foundations. Piles. Piles are long, slender columns made of concrete, steel, or timber that are driven into the ground to a depth where the soil or rock is stable. Piles can be used to support individual columns or entire structures. Caissons. Caissons are large, watertight chambers made of concrete or steel that are sunk into the ground to a depth where the soil or rock is stable. Caissons are often used for large structures, such as bridges or buildings. Shafts. Shafts are vertical excavations made in the ground to a depth where the soil or rock is stable. Shafts can be used to support individual columns or entire structures. Piers. Piers are short, thick columns made of concrete or masonry that are used to support structures in areas where the soil is weak or unstable. Advantages of deep foundations. Increased stability. Deep foundations provide increased stability to structures by transferring the weight of the structure to a deeper, more stable layer of soil or rock. Reduced settlement. Deep foundations can reduce settlement of structures by providing a more stable base. Improved load-carrying capacity. Deep foundations can improve the load-carrying capacity of structures by providing a more stable base. Disadvantages of deep foundations. Higher cost. Deep foundations are generally more expensive than shallow foundations. Increased construction time. Deep foundations require more time and effort to construct than shallow foundations. Specialized equipment. Deep foundations often require specialized equipment such as pile drivers or caisson excavators. Applications of deep foundations. High-rise buildings. Deep foundations are often used for high-rise buildings to provide stability and support. Bridges. Deep foundations are used for bridges to provide stability and support in areas where the soil is weak or unstable. Industrial structures. Deep foundations are used for industrial structures, such as factories and warehouses, to provide stability and support. Offshore structures. Deep foundations are used for offshore structures, such as oil rigs and wind turbines, to provide stability and support in deep water. Design considerations for deep foundations. Soil conditions. The design of deep foundations must take into account the soil conditions at the site, including the type of soil, its strength and its stability. Load-carrying capacity. The design of deep foundations must ensure that the foundation can carry the loads imposed by the structure. Settlement. The design of deep foundations must minimize settlement of the structure. Durability. The design of deep foundations must ensure that the foundation is durable and can withstand the environmental conditions at the site. Construction methods for deep foundations. Pile driving. Pile driving involves driving piles into the ground using a pile driver. Caisson excavation. Caisson excavation involves excavating a large, watertight chamber in the ground. Shaft excavation. Shaft excavation involves excavating a vertical shaft in the ground. Pier construction. Pier construction involves building a short, thick column to support a structure. Thank you for watching.